All right, good night, everyone. This would be our second tutorial. So I'll be just starting off from where we left off, which was the end of pseudocode. I found three more questions so that we can just keep practicing how to construct algorithms in pseudocode. And then later on, we will go into flowcharts and then we'll have a chance to practice them. Okay, so let me get the slideshow up. All right, so the question 6. A certain seller company provides the following rates for voice calls. For the first 10 minutes, it is $1.50 per minute, and any additional minutes, it is 50 cents per minute. Write an algorithm that reads an integer value representing the number of minutes used for voice calls and calculates and prints the cost of calls. Samara, would you like to solve this? Okay. I'll put the question in chat so you can still see it. Okay, so you can tell me what to start with. All right, wait, hold on. Okay, so declare mins as an integer. All right, mins is declared as an integer. Then print duration of call. Print duration of call. And then read mins. What to put after this? So if mins is less than or equals to 10, want to declare cost in the if statement, or you want to declare it up here? All right, no problem. Just to explain why, for those who are watching, if you declare a variable down here, well, it wouldn't necessarily be affected if it's a loop. If it's a if statement, but if it was a loop, then it would keep continually declaring every time it iterates. So it would then knock out any values that were inside of it. So it is best to initialize any values outside of loops or conditional statements. And so I'll just copy this and put it up here. And I see you said cost equals cost multiplied by 1.50. What do you put next? So else cost equals 10 times 1.50 plus min star 50. All right, just a couple things here. Up here, I think it might be better to let cost be equal to minutes times 1.50, because if nothing is in cost, then it would be multiplying 0. So we'll just make this mins here. And then for the else, I think we should subtract 10 from minutes just to make sure that we aren't multiplying 10 more minutes that's already taken care of over here. So let's just declare a different variable up here just for consistency. Add minutes. So additional minutes would be equals to minutes minus 10. So then you would put that in here. And this will be the end of the if. Right, so we'll end the if statement here. And then print cost of call equals, and then cost, and then stop. All right, it looks like this algorithm can work. So we have our variables up here, and then we read in our call time. And then if it is less than or equal to 10 minutes, then it'll just calculate the cost there. And if not, then it will calculate at 10 minutes and then at the additional rate and then print it out. So this seems to be the answer. I actually didn't do the answer because I wanted to work through it, but this answer looks good. So we can move on to the next question. Question 7. A soft drink manufacturer sells 5 soft drink flavors: bananas, cherry, mango, orange, and pineapple. The company knows that banana and pineapple are the 2 best-selling flavors and is carrying out a poll to determine which of these 2 flavors is the more popular among its customers. Write an algorithm to find out the more popular flavor and the number of votes it obtained. Assume that 100 customers participate in the pool and that there is no tie. All right, so I'll put this question again in the chat. And then we can try to solve this algorithm. So just starting with start and stop. Samara, what would you start with? All right, so declare. All right, so ban and pin for banana and pineapple as integer. All right, then next. All right, print enter votes for banana and then read EAN and print enter votes for pineapple and read PIN. So if BAN is greater than PIN, print banana is the more popular and else print pineapple is the more popular flavor. And if and stop. All right, so the algorithm here looks good, but there's only one small problem. The not sure what this one because I didn't use the 100 information. Um, Perhaps you could say in this case, if banana is greater than, let's say, 50, then it'll write banana is the more popular flavor, and else pineapple is the more popular flavor. Because at least by 50, that should be the majority line. So I think we can just leave it as 50 there. But another thing is that we should also put the number of votes each fruit obtained. So here I'll just put with, um, let's say BAN votes, and down here with PIN votes. All right, no problem. All right, so it seems like if this algorithm is complete now, we have our variables and we read in the votes for each fruit. And then if banana is above the majority line 50, then it would print out that banana is more popular and the votes that it received. And otherwise, it would do so with pineapple. All right, so since this looks good, we can go on to number 8, which is kind of a bit long, but we'll still do it. A primary school is conducting a survey on the popularity of certain colors. Students are asked to vote for any of the 4 choices: red, blue, green, or none. If red, blue, or green is not the favorite, the students vote for none. Write an algorithm to find and print the number of students that vote for each of the colors red, blue, and green. Have a total number of students who voted for red, blue, or green. Assuming on the day that of the survey there are 150 students are present, and also assuming that all votes are valid. So I'll copy this into chat. And then we'll go down to the next slide to write our solution. So I'll give you time to read the question, and then you can tell what you'll start with. All right, so Samara, what would you start with? All right, so declare R, B, G, and N as integer. Good night, Anwar. We're just working through some additional pseudocode questions. I'll put the question back in the chat for you to look at. So you can also try to help out with the solution. The recording would be uploaded to the YouTube channel, and this PowerPoint will also be placed in the Discord group, so you don't have to worry about missing anything. Right, you're gonna put RGB and N as string, and then color as integer. Okay, so you would switch this to string, and then declare color as integer. All right, so what would you put next? All right, so print enter favorite color. Switch back the variables. So you would put this as integer and then color as string. Okay. Color string. Okay. So then I presume you would read color down here. Right. So read color. All right. So next. Any suggestion for what to put next after reading in color? Right. Holding on. I'll let you have time to think. Saying if still but not set up right. Okay, no problem. First, you can probably have R equals 1, 3 equals 2, B equals 3, and N equals 4. All right, so that's what we're going to initialize those four variables as at 1, at 2, at 3, and at 4. Oh, you're going to have like a menu. Okay, right. So I'll just format this and put the options above the prompt, if that's okay with you. Right, so menu, so red, so 1, red, so 2, green, 3, blue, and 4, none. All right, so we'll get rid of color. So then what we'll read this option into? So do you want to leave color as an integer just so that it can store in the choices? All right, so I'll just put color back up here. Right, so after reading in color, what would you do next? So if color if color equals R G or B, well, their values being, or so we're gonna still have R, G, and B declared as something. So I was just asking if if we're gonna still, you said higher up have R equals 1, G equals 2, B equals 3, and N equals 4. So I was just asking if we're gonna be still doing that. Okay. All right, so let me just initialize all of these up here. I'll just put them on the same line just to save space. G equals 2, B equals 3, and N equals 4. All right, so putting this here, and then just putting the keywords in capital. So here would read if color is equals to R, or in fact, I should just put this over here just to make it clearer. All right, so if color is equals to R, or color is equals to G, or color is equals to B, what would you put next? Color equals N. Okay, so if color is equals to any of the options for red, green, or blue, they're going to assign color to 4, which is not none's number. So you're going to put 4 into color. All right, so removing this line. All right, so we're gonna just stop for a second and restart the meeting because we're running out of our 40 minutes. So I'll just end the meet now and then I'll restart promptly. All right, so ending now to restart. All right, so after that small interruption, let's just continue on where we left off. So the first line after the if statement, we took out color equals N. So what we replace it with? Alright, so I'm missing one. Okay, so I'll help. All right, so hmm. All right, so I think in this case, we'll get rid of the if statement. So perhaps if we just leave our BG and N as the counters for each color instead of letting it store the options for the menu. All right, so we'll just take this out too. So you want to have this, you say you want to have a loop in here. So maybe we can I've got a while loop or for loop and then perhaps have it loop for 150 times for each student. Okay, so you said up here that you know you're missing a loop. So perhaps I was just asking if we could have like let's say a for loop or a while loop and then have the upper limit as 150 for the 150 students. So we would then put this within the loop. And then as it iterates, it will read in what is in color into, let's say, these variables here with an if statement. Understand? All right, so let's just implement that now. So just to keep it simple, we can use a for loop. So 1 to 150 do. Pardon me for a second, have to save this meeting quickly. All right, so for 1 to 150 do, then let's just put an if statement in here. All right, so if color equals 1, then R equals R plus 1. So if 1 is inputted in here, then the number for red would keep increasing. So then let's just copy this for the other options. Oh, this is getting a bit small now. Let me get rid of this up here so I can make it a bit larger. All right, so continuing on. Copy this and just put else if, and then for here we can just put else, and then replace these with G, B, and N, and then replace these colors up here. All right, do you see anything else that we can do with this for loop, or do you think we can end it here? All right, why do I have double equal signs? So in this situation, this would be checking for equivalence. So if color is equals to 1, so if the value that is in color is equals to 1, it would then return, if it then returns true, then it will run the code. But down here, the single equal sign is mainly used for declarations and for assigning variables. So down here, if up here is true, then it will assign to R plus 1. So double equal signs are for equivalence, while single equal signs are for assigning or declaring variables. Understand? All right, cool. Okay, so is there anything else we should include in this for loop, or? All right, so end the loop, and then we should have a variable for total. All right, so put total up here, and then total equals R plus G plus B, right? And then print the number of students that voted for R equals red. Equals R, and then repeat for each color. All right, so G for green and blue, put B. Let me see if I can put this as columns. Right, so I'll just leave it as two columns just so that it'll still be readable. So then print total votes for red, blue, and green equals total. And then stop. All right, this solution fulfills all the requirements that's been asked. It asks for the input of colors, and then it also reads in those colors and then adds a counter for, it increments a counter for each color that is entered. All right, I should put this inside of here. Right, so it'll keep repeating for the entry of the color. And then after repeating for 150 students, it then reads all of those that voted red, green, or blue into total, and then prints out the number of students that vote for each color and those who voted for those three colors combined. So this solution seems good. All right, so before we go on, are there any questions on pseudocode that anyone has? All right, so Samara is okay. How about you, Anwar? All right, so Anwar is okay. So then we can move on. I don't have much editing to do from here out, so I'll go into the slideshow. All right, so I'll be giving you a brief introduction into flowcharts, which is also something that you are going to need to know for programming in general. So while pseudocodes are a way that algorithms can be shown in text, flowcharts are ways that can be shown graphically or visually, as this slide shows. So these notes were taken from a book prepared by Isaiah Carrington, a person who at some point worked with this. I will work with this organization. I would share this book with you later on, but these notes did come from that book. All right, so starting off, what is a flowchart? A flowchart can be defined as a visual representation of an algorithm. Flowcharts make use of various shapes and symbols to visually represent structures that exist within an algorithm. So why are flowcharts useful? So there are times when a visual representation might be more appropriate and easier to display and understand than a worded one. So flowcharts are then use these various symbols to which then conveys different meanings to show how the program would run logically. So then we'll look at the more common symbols and their meanings. So starting off, we have the flow line, which is going to be represented as an arrow. These show how the program is supposed to flow from one shape or one construct to another. Next is the oval, which is largely used for start and stop, which shows where the algorithm begins and ends. And then there is the parallelogram, which is used for input and output. So whenever you want the user to enter a value or a string or anything, or you want to display that value or string to the screen or to the user, then you would use a parallelogram to display that. The rectangle is used for processes, which can include mathematical calculations and assigning variables, or even declaring variables as well. And then there's the rhombus or the diamond. This is the shape that's then used to evaluate a given condition, and it would then do one of two or many results depending on the condition's results. So this shape would be used for if statements. It'll also be used for loops. So the condition in here would, instead of it being a for loop, if let's say I is equals to A in a for loop or a while loop or in any other loop, it would then show I is less than A or a certain number. So as long as the condition hasn't been met, it will flow down a certain line, and then when that condition is met, it'll have a separate branch for when it breaks out of that loop. All right, so I'll just show you one example. So for this problem, it'll be displaying only even numbers within the range of 1 to 15. So here is a very simple algorithm. So here you have your begin and end. And then here you have declaring number as integer. So this would be the number that would be being tested to show whether it's even or not. And then down here, it would show this number then being incremented from 1 to 15. And then within this for loop, if number is modulus 2 equals 0, so if when number is divided by 2, there's no remainder, meaning that it's completely divisible by 2, which then means that is an even number. Then it'll display the numbers. Sorry about the 6 here. Let me just alter this. This was there when I was editing the slideshow. When I was copying from the textbook. Right, so let me put this back. All right, so it would then display the number. It'll print number out to the screen and then end the if and then end the for, and then that's the end of the program. So how this algorithm would be represented on a flow chart as a flow chart, you would have your oval showing begin where the algorithm begins. And then here's your flow line. And then here's your rectangle showing the process being done. So here number is being declared as an integer. And then this flows to another rectangle, which is where number is being assigned the value of 1. So then you come down to this shape, the rhombus or the diamond. And then inside this condition, if this number is less than 16, meaning if the number, meaning that this will keep going until number becomes 15, then if number is less than 16, it'll follow this true line and then have another condition, which is now the if statement. If number mod 2 is equals to 0, meaning if the number is even, then it would display the number and then it comes back up here just above this condition diamond up here to show that you're now going back into the condition. So now if number is still less than 16, it'll continue down this line. But if number is not divisible by 2, if number modulus 2 is not equals to 0, then it'll come up here to false, and then we'll come back above this for loop diamond, meaning that is now out of this condition and is now going back to the previous condition. So if number is less than 16, and by the time we get to 15 and all the even numbers, but then have it printed out, and number then becomes 16, it would then follow this false line as this loop has already run out. It'll follow this false flow line down to this other oval, which then represents stop. All right, so everyone understands? All right, so are there any other questions related to flow charts? All right, so we can now try to practice flow charts. So We'll now try to practice these flowcharts by converting the pseudocode questions that we've done before. So the ones that we've done last week and the ones that we've also done earlier this session into flowcharts. So I'll be using an interactive whiteboard called the Jamboard so that you can write the flowcharts, and I'll also present the Jamboard on the screen for those who are watching the recording later on. I'm also going to save this Jamboard and then post it in Discord later. So I'll be using this link here. I'll put it in chat. All right, so let me copy this. All right, so let me know when everyone has joined the Jamboard. All right, so I'm seeing our students on here. So let me just switch screen. All right, so let's come on and show this Jamboard. Okay, so I'll just put the algorithm on the site here just so that everyone can still go off of it. All right, so give me a moment to copy number one. All right, so here is the algorithm. So are there any volunteers to attempt converting this into a flowchart? Okay, everyone has used the Jamboard before, right? All right, cool. So you have you drawn on one before? All right, cool. So would you like to volunteer to start? Okay, so Samara will do this one and then Anwar can do the next one. All right, so the screen is yours. And remember to do the rectangle to when you're declaring the A, B, and C. All right, you don't have you don't have any more space to go on. All right, so we can just put it on, we can just start from the next slide. I'll just put a circle connector. So you can just, so you can just say it's the same, all right? My apologies. Hold on. All right, so for just for the no line, right? I'll just put this connector down here. And then, so you can just continue on the next slide when you're ready, okay? All right, so let me go back over here. So you can start on the next slide, right? All right, so looks like you're done with this. So let's start from the top. So we have the start oval here. Then we declare A, B, and C. Then it has the prompt here. So print enter equals enter tree numbers, and then it has the first condition here. And if A is larger than B or C, then you print out A. And if not, come over to the next page, then test if B is greater than A and B is greater than C. And if so, then you print B. If not, then you print C and then you stop. All right, so this looks good. So I'll break here again temporarily so that we can restart probably because I'm about to run out of time again. So when we restart this meeting promptly, and we can start on question 2. All right, so now for the last stretch of this meeting, we'll continue on from number 2, where Anwar will attempt to convert this algorithm. So Anwar, the screen is yours. I just want to point out, so If you want a rectangle or a parallelogram, then you can just use the shape function that it would be just above the text box, and you can copy one from there, just so you won't have to keep drawing. And if you can just use a bar and then draw the edges on it. But this is just for future reference. All right, I'll open the next slide for you to draw on, to keep drawing on. Can you write I equals 0? Um, yes, you can. So I know if you're on the next page or not. I'll copy the algorithm onto this slide too, just so you don't have to keep going back from slide to slide. All right, so I'm gonna next slide for you. Um, for the most part, you are going right. It's just that at this for loop, I don't think you have that you are reading in um array I from what I see. Okay, so from this point, which would be equivalent to this line here, the next thing you should have had was read array I, which um, just so that I don't erase what you currently have, I'll just draw a line here. So here then you should have a parallelogram saying um, read a parallelogram here saying read array or looks like Anwar left. So let me just correct what is here. All right, so read array I. Anwar's joining back. Right, so in this for loop, we'll have read array I, and then as long as y is less than n, so I'll just slightly change this to I is less than n. All right, so while I is less than n, it'll keep reading in. All right, no problem. No problem about that. So as long as I is less than n, it'll keep reading in array I, and then we'll go back up here and then keep testing. And then if it is false, if I then becomes equal to n or greater than n, then it will come back down here to rejoin this line, which would then be the false line. So then it would read in j equals 1 and then come to this for loop here. So here I'll just edit it to say while j is less than n, and this condition can stay. So, and what can you can continue from here on if you understand what I said. If not, then I can continue this algorithm. Yes, I am currently talking. Also, we're having technical difficulties. So, Samara, can you continue? Wait, Anwar is joining back. So, can you hold on? Right, Anwar, can you hear me? Anwar, can you hear me? Oh, so you can't hear me at all. Oh, okay. All right, Samara, can you still hear me? Okay, so Anwar can hear me now. Okay. All right, so just to explain what I said just now. All right, so I just edited what you had here to have the condition while I is less than n. So if this is true, then it will read in array I. So just including this line here. And then after that, it'll then come back to up here where it'll test this condition. And then if the condition is still true, then it'll read in the values that are in the array. And then if it then becomes false, so if I is then equals to n, or if I is greater than n, then it will continue on this line to where you are now. So I just changed this condition slightly, and this one can remain as is. Just that when you do have not the false condition, you might have to draw a redirect line somewhere. Understand? Okay, no problem. All right, so at this point, so we had this diamond, I is less than n, so this would be up here, this for loop for I to n. So at this condition, I will be testing if I is less than n. So if this is true, then it'll come up here to this parallelogram where it'll be reading in array I. So whatever value is within the array at the position of I, wherever it is when it increments. So then when it finishes reading that particular value, it comes up here back to this condition and then tests whether I, which is going to be incrementing, is still less than whatever n is set as. And if it is still less than n, it will keep running through this code. It'll keep running in the value that is at that position I, and then come back out here. But if I then is equals to n, or is greater than n, then the condition then becomes false. So it will follow this false line and then would continue on with the rest of the program. So j is equals to 1, and then this for loop here, which I changed to where j is less than n, because that will be the same condition. So it'll be looping for as long as j is less than n. And then within this for loop, you have this condition here. So all I said was that since you have it here, it's fine. It's just that you would have to then, let's say, draw down here for your false line and then reconnect it over here if there's not enough space, and then continue down here as your true line. So this piece of code executes as long as j is less than n while it increments. So this would be the true line. But when this condition expires, you're going to have a separate line, the false line, for when the condition expires. So I was just saying you're going to have to possibly have another line here in case the condition expires. But other than that, you're going good so far. Right, so Anwar, you can continue on if possible. I only see one person on Jamboard. Who is this, by the way? Oh, you're on your phone. Okay. All right then. So I'll just finish out this um algorithm. Okay, no problem. All right, so the tiger is you, Samara. Okay. Right, so I'll continue out this algorithm and then we'll let Samara do the next one and then we can finish the session there. Right, so continuing on, if the array j is less than array j minus 1 and array j minus j plus 1, then it would print array j. All right, so I'll just put this here. So print array j, make this a parallelogram. And then let it come back up here to retest the condition. So here, if it isn't less than that condition, then it would then come back up to this statement up here. It'll come back up to this j is less than n condition. So just to label what I have here. So for this condition, array if array brackets j is less than array j minus 1 and array j is less than array j plus 1, when this is true, it'll print out array j as in the algorithm here, and then would come back up here. But if it is false, then it would come back up to this condition here. So this runs while it is true. So I will put a true label here for consistency. So this block of code will run as long as the condition is true. But if the condition is false, the for loop would then end, and according here, it would then stop. The program would end thereafter. So I'll just put this in here. and then put stop. Right, so that is the algorithm. So up here, it starts, then you define n, j, and I as integer, and then you declare the array. So now it has for the display, print how many numbers do you want to enter. And then, oh, you mistook read n here. So I'll just put this in here. All right, so parallelogram. All right, so read n, and then it would rejoin this program. Print n numbers, and then here it initializes I equals 0, and then testing the conditions. So if I is less than n, then it will read array I, come out, retest the condition, and if it then ends up being false, it'll then come out here, print, it'll read 1 into j, and then here it will test the condition, j is less than n for loop. So while it is true, it'll then test again if array j is less than array j minus 1 and array j minus array j plus 1. So then if this is true, then it will print out array j. Come back up here, test the condition. But if it is false, then it'll come down here and then retest the for loop condition. So if j is still less than n after increments, and if it is no longer less than n, then it will end the program and stop. All right, so everyone understands that? All right, for the most part, yes. Okay, no problem. All right, so although I said that you can do the next one, the time is 9 p.m. So this session would have to come to an end now. But this was still a good session. We did a couple more pseudocode algorithms. Like we got introduced to the concept of flowcharts, and then we had some practice doing these flowcharts. So perhaps next week we could continue on, or we may start on basic C programming, all depending on what the lecturer says. So this is the end of the session. Thank you to everyone who came, and I hope you all have a good night. Oh, he had class on, oh, he actually did not have a class on Wednesday, but I hope his scheduling has been worked out. We've worked over time, so I'll check with him to see if he will still carry on the classes, and hopefully he will carry on the classes on Wednesday. All right, so are there any more questions? Uh, yes, he had the wrong time, so hopefully that's no result. All right, so since there are no questions, then we can end here. So good night again to everyone.